All right, let's take a look at the last two examples from the section. Example 11. Both the series of 1 over n plus 1 and 1 over n plus 3 from n equals 1 to infinity, both of these series diverge. True or false? If I take these two divergent series and I subtract them, such as what's shown there, does that new series converge or diverge? Does it diverge? True or false? Does this series diverge? False. This series actually converges. How do we know this? Well, we know this because this was the telescoping example from example 3. So this is the telescoping series. Which we have a video about. So from example 3, we actually went through this and showed that it does converge. So this is interesting because it has to do with the linearity of convergent series. So just because you have two series that themselves are divergent, depending on how you combine them together, whether you multiply, or you divide, or you add or subtract, you could add or subtract, multiply, or divide them in such a way that the issues present in the original series that cause each of them to diverge independently of one another, if you combine them in the right way, you might get those incompatibilities to sort of cancel each other out and create a new series that doesn't have any issues that cause it to diverge, and therefore sort of like you get the divergences to cancel out in a sense, in a really informal sense. So yeah, just because you have two divergent series, you could feasibly combine them in a way to create a series that may not also diverge. Okay, example 12. So let's take a look here. 0 is the same thing as adding up an infinite number of zeros. That's correct, right? 0 is the same thing as 0 plus 0, which is the same thing as 0 plus 0 plus 0, which is the same thing plus really adding any number of zeros. So even if I add up an infinite number of zeros, that's still, at the end of the day, equal to 0. So this line here, I'm going to put a red check because there's nothing wrong with that. That's a true mathematical statement, no issues. Okay. So now, the next line, we're going to say that this is the same thing as this. So 0 is the same thing as 1 minus 1. That's true. There's no issues there. That is a valid statement. Now, I'm going to take this series, and since I'm adding up a difference of two things, I'm going to just distribute the summation symbol to each term. So I'm going to add up an infinite number of ones, and I'm going to add up an infinite number of negative ones. Okay. So this line right here is where the issue comes into play. So I'm going to put like a little star here. There's an issue right here. So then, if you didn't notice that was a problem, and many of you might not think that there's anything wrong with this, and if so, that's fine, bear with me. We're going to come back to why this is the problematic line, or the logical step that's problematic. But for now, let's just suspend our disbelief. So if this is true, if this line were valid, then we could say we basically have 1 plus 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 1 forever, and then we have minus 1 minus 1 minus 1 minus 1 minus 1 minus 1 forever. Because we've got an infinite number of positive ones and an infinite number of negative ones. So then with an infinite supply of both positive ones and negative ones, I can regroup them because addition is commutative. I can swap the order of addition and still have the same thing. So I can regroup all of my, I can leave one of my positive ones where it is, and then I can just pair the infinitely many more remaining positive ones with the infinitely many negative ones that we have at our disposal. Group them as pairs so that they each cancel out to 0. And then I've just shown that 1 is equal to 0, which clearly is incorrect. So what is wrong? Well, it does come down to this starred line, third from the bottom. The issue is from here to here. That's the issue. You can only split, so let's describe it this way. Only can split apart series if each part is convergent independently of the others. So the issue here is the fact that these two series by themselves, are divergent series. That's the issue. So just because this is convergent, when you split it apart, you do get two divergent sequences. And if you have a divergent sequence, that means you can't reasonably actually assume that you do have an infinite number of these positive ones and then get to play with them. If your series is divergent, you're not allowed to play with it. It's divergent, it's nonsensical. Any conclusions you try to draw from it will likely be utter nonsense or coincidentally true, but just coincidentally. So you can only split apart series if each part is convergent independently of the others. And this these two series here, n equals 1 to infinity of 1, and the series of n equals 1 to infinity of negative 1 are divergent series. And that's the issue.